In this video, we want to learn about adding, subtracting, and multiplying polynomials. Let us start with this example. We have a polynomial here, as you can see, another polynomial here, and we want to add these two polynomials to each other. First of all, note that these two brackets around these polynomials is not really necessary, and so you can eliminate these brackets. For adding polynomials, we group like terms. But what are the like terms? The terms that the variable have same degree. So x to the 3 and x to the 3 are like terms. Negative 6x to the 2 and 4x to the 2, because we have in both of them x to the 2, are like terms. Here we have a 5x, but here in the other polynomial we don't have any term to group with 4x. And finally, we have a constant 4, which is in the same group with negative 7. So, for adding polynomials, we group the like terms. So, we do it this way. X to the 3 plus x to the 3. This is one group. Then we have negative 6x to the 2 and 4x to the 2. For the 5x term from this polynomial, we don't have any term from the other polynomial. So we leave 5x by itself, and finally we have a group, which in that group we have 4 and negative 7. These are the constant terms of these two polynomials. Now we add these like terms. 1x to the 3 plus 1x to the 3 is 2x to the 3. Negative 6x to the 2 plus 4x to the 2 is negative 2x to the 2. Negative 6 plus 4 is negative 2. We have 5x, and finally 4 minus 7 is negative 3. This is the answer of this question. Please attention. Really, this middle step is not necessary, and gradually you have to be able to move from here to this answer. And it's not really hard to find the answer without the grouping. X to the 3 plus x to the 3, 2x to the 3. Negative 6x to the 2 plus 4x to the 2, negative 2x to the 2. 5x is the single term with x, so we write the 5x here. And finally 4 minus 7 is negative 3. So the grouping, which is this step, is one step that gradually you have to jump over this step and find the answer right away. Look at the next example. Here we want to subtract these two polynomials. These two polynomials here are the same as previous example, but here we want to subtract these polynomials from each other. Again, we do the grouping, but attention, between them is a minus. So we have x to the 3 minus x to the 3. And attention, this minus is for all the terms in this bracket. So you have to apply this negative in each term here. Then we have negative 6x to the 2 minus 4x to the 2. Because don't forget to apply the negative in the bracket. Again, 5x is the only term with x, so we don't have any corresponding term here to group with 5x, so we leave the 5x here. And what is the last group? The last group has two terms. 4 minus negative 7. Minus 7 is plus 7. Now let's simplify each group. X to the 3 minus x to the 3 is 0. So from this group we have nothing. It's 0. What about this? Negative 6x to the 2 minus 4x to the 2 is negative 10x to the 2. Then we have 5x. 4 plus 7 is 11. And this is the final answer for this question. Now look at these examples. First, we want to subtract these two polynomials from each other. Let's try to do this question right away in one step. We have 5x to the 3, but we don't have any term corresponding with x to the 3. Here we have only x to the 2, x and a constant. So in the answer we have 5x to the 3. Then we have 4x to the 2 minus 2x to the 2. 4x to the 2 minus 2x to the 2 is 2x to the 2. Then we have minus 6x minus 6x. So basically we have negative 6x plus 6x, because minus times minus would be plus. Minus 6x plus 6x is 0. These two terms are negative of each other, so the sum of them is 0. So we don't have any x, any term with x. We have 0x, which is 0. And finally we have minus 10. Minus times 10 is minus 10. So as you can see, the grouping step is not necessary to do for every single question. Gradually you have to be able to subtract and add polynomials in one step, like this example which I did here. In the next question, we have a little harder example, because as you can see, we want to subtract two polynomials, but we have a number outside. What we have to do with this? First, you have to do the multiplication, then you subtract the answer of this from the answer of this. So first we do multiplication. 2 multiplied by the first polynomial would be 2x to the 2 minus 4x plus 6. 2 times x2 is 2x to the 2. 2 times 2x is 4x. 2 times 3 is 6. Now for the other polynomial, we want to multiply negative 3 in the bracket. Then we have negative 3x to the 2 minus 3x. Now add and subtract like terms. 2x to the 2 minus 3x to the 2 is minus x to the 2. Minus 4x minus 3x is minus 7x and 6. This is the answer of this question. Look at this example. Here, first we have to multiply 2x in the bracket, negative 3 in the bracket, and this negative in the bracket. Then we add and subtract similar terms. If we multiply 2x in the bracket, we have 2x times 5x is 2 times 5 is 10. X times x is x to the 2. 2x times 4 is 8x, because 2 times 4 is 8 and we have x. Now multiply negative 3 in the bracket. Then we have negative 3x to the 2 minus 3 times 2x is minus 6x. Apply the negative in the bracket. If you distribute negative in the bracket, then you have negative 2x to the 2 minus 5x plus 7. Now we have to look for like terms. 10x to the 2 minus 3x to the 2 minus 2x to the 2 is 5x to the 2, because 10 minus 3 minus 2 is 5. Now look for the terms with x. 8x minus 6x minus 5x is minus 3x. 8 minus 6 is 2. 2 minus 5 is negative 3. And finally the constant terms. The term that is constant is 7. If you look at the other terms that here we have, they all involve x. So we don't have any term that is constant except 7. So plus 7. And this is the answer of this question. Now look at this example. We have a polynomial, another polynomial, and we want to multiply these two polynomials by each other. Basically, here we have a binomial, and here we have also a binomial, because we have only two terms in each bracket, so they are binomials. For multiplying an expression in the form of a plus b by another expression in the form of c plus d, like this example here, when in general we want to multiply a plus b by c plus d, the process is this. You have to multiply every single term from here in every single term from here. So you have to multiply a by c, which is ac, then a times d, which is ad, then you move to b times c, bc, b times d, which is bd. For doing this, we have a famous acronym, FOIL method. We say this FOIL method. What is FOIL method? If you pay attention in this process that we multiply the first bracket in the second bracket, first we multiply a by c. So we first multiply first terms. Then after we multiply first terms, we multiply outer terms, a by d, ad. A and d are the outer terms in these brackets. After that, we have bc. What is bc? If you pay attention, b and c are the inner terms, so we multiply then inner terms, so which is I. And finally, the last terms that we multiply are the last terms, b and d are the last terms that we multiply and are the last terms in each bracket. So we use this FOIL acronym to remember the way that we have to multiply these two brackets by each other. But is it really necessary to memorize this acronym? No. It's very simple. Multiply each term from this bracket in each term in the other bracket. A times c, a times d, b times c, b times d. So let's back to our question. We want to multiply these two brackets by each other. We don't need to memorize anything. Simply multiply each term by each term. 3x times 4x is 12x to the 2, because 3 times 4 is 12 and x times x is x to the 2. Then 3x times negative 5. 3 times negative 5 is negative 15, but we have x, so negative 15x. Now that we are finished with this term, we've multiplied the first term in each term. Now is the time to multiply the second term in each term in the second bracket. So now we multiply 2 by 4x, which we have 8x, and 2 times negative 5 is negative 10. We have to simplify our final answer. The final answer would be 12x to the 2. These two are like terms. Negative 15x plus 8x is negative 7x minus 10. This is the final answer for this question. So here we learned about multiplying polynomials, and you can use this rule for multiplying any polynomial by another polynomial. Look at these examples. Again, we have a binomial multiplied by a binomial. The answer is 2x to the 2 times 5x is 10x to the 3. 2 times 5 is 10, x 2 times x is x to the 3. Now 2x to the 2 times negative 4 is negative 8x to the 2. Then we multiply this by this, which we have then negative 15x to the 2, And finally, this by this, negative 3x times negative 4 is 12x. Negative 3 times negative 4 is 12, and we have x in one of the terms, so 12x. Simplify the answer, 10x to the 3 minus 8x to the 3 minus 8x to the 2 minus 15x to the 2 would be negative 23x to the 2 and 12x. This is the answer of this question. Look at the next example. Here we have a binomial multiplied by a trinomial. Follow same method. Multiply the first term in each term here, then move to the next term and multiply these 3 in each term here. So you have to be careful not to miss any term. 2x times 3x to the 2 is 6x to the 3. 2x times negative 6x is negative 12x to the 2. 2x times 8 is 16x. 8 times 2 is 16, and we have x. Now we have to multiply 3 in the terms. 3 times 3x to the 2 is 9x to the 2. 3 times negative 6x is negative 18x. 3 times 8 is 24. Now we simplify this answer. We have 6x to the 3. This term and this term are like terms. Negative 12x to the 2 plus 9x to the 2 is negative 3x to the 2. 16x minus 18x, negative 2x, plus 24, which is the constant term. And this is the answer of multiplying binomial by a trinomial. Look at this example. We have a binomial multiplied by another binomial, and this seems relatively simple example. We can use the FOIL method to multiply these two binomials by each other. But let me tell you an identity that you can use for multiplying these binomials by each other faster. And I highly recommend you to memorize this important identity. You can use this identity for factoring and for finding the multiplications of expressions. So this identity is really, really important. What is the identity? A plus b times a minus b, or a minus b times a plus b, is equal to a to the 2 minus b to the 2. Maybe you are familiar with this identity. Whenever we have an expression like this, we can factor it with this formula. So sometimes we have this expression, we want to factor it, we use this identity this way. From this, we can factor it this way. But here, we want to use this identity in this form, that we have this expression as here, and we want to find the answer. We want to multiply this bracket by this bracket. But why we can use this identity for this question? Attention, here we have a minus b times a plus b. The 3x is like your a, and the 2 is your b. So we have a minus b, which is the first bracket, times by a plus b, which is the second bracket. So we can use this identity. Again, this is your A and the 2 is your B. A minus B times A plus B. You don't need to waste your time. Multiply term by term. If you do it that way, you are going to have 4 terms here. But in this way, you are going to have only 2 terms, and the answer is simplified. If you do it with the FOIL method, in your answer you have 4 terms, you have to simplify it, and then at the end you have only 2 terms. So definitely using this identity is better. So the answer is A to the 2. What is A? 3x. So the answer is 3x to the 2 minus B. What is B? B is 2. 2 to the 2. So the answer is basically 9x to the 2 minus 4. Let me show you what happens if you multiply each term of this bracket in each term of this bracket. 3x times 3x is 9x to the 2. 3x times 2 is 6x. Negative 2 times 3x is negative 6x. Negative 2 times 2 is minus 4. This cancels with this, and only we have 9x2 minus 4, which is this answer. So the thing that we learn from this identity is that this relation, this identity, is very important. So memorize it, and then you can use this relation for doing questions like this. Look at the next example. Again, we have A minus B times A plus B. The answer is A to the 2. So the answer is radical x to the 2 minus 3 to the 2. Radical x to the 2, radical and power 2 cancels. X, 3 to the 2, 9. So the answer is x minus 9. Look at these examples. At first, it seems really challenging question, but if you pay attention, A minus B, A plus B. So this is like A minus B, A plus B. What was the answer if you remember? The answer is A to the 2. What is A here in this example? Radical 4 plus H to the 2 minus B. What is B? B is 2 to the 2. If we simplify, the radical and power 2 cancels, and we have 4 plus H. 2 to the 2 is 4. So this power and this radical cancels. We have only 4 plus H. 2 to the 2 is 4. 4 minus 4 is 0. So the answer, the final answer of this question is only H. So the answer of multiplying this bracket by this bracket is H. And attention that this is not really a polynomial. This is just an expression with radical. So these are radical expressions basically that we multiply by each other, but the process is the same as multiplying polynomials. Look at the next example. This is a little challenging example. And as you can see, the problem is that we have 4 brackets. We want to multiply them by each other. You can do it in the normal way. First, you can multiply these 2 brackets by each other. Then multiply the answer with this. And finally, multiply the answer of all of that by this. And attention, the order of multiplication is not important. For example, maybe you like to start from here, multiply these 2 by each other. Then multiply the answer by this, and then the final answer with this. The order of multiplication doesn't matter. But what is the best way to find the answer in the fastest way? Look at here. We have A minus B, x minus 1, times A plus B, x plus 1. So We can use the identity a to the 2 minus b to the 2. So the answer of multiplying these two brackets is x to the 2 minus 1. So let me write this in a better way here. So this equals to x to the 2 minus 1. So we multiply these two, and this is the answer, x to the 2 minus 1. And we leave the other brackets here. Now, again, we notice that we have a minus b times a plus b. Look at these two brackets. The terms are the same. The only difference is this minus and this plus. Again, we use the identity. x2 minus 4 times x2 plus 4 is a to the 2 minus b to the 2. Attention, this is your a and this is your b. So the answer is a, which is this, to the 2 minus b, which is 1 to the 2. And don't forget to write the last bracket, which is x4 plus 1. Simplify the first bracket. X to the 2 is x4 minus 1 times x4 plus 1. Again, we can see that we can use the identity a minus b times a plus b. What was the answer of a minus b times a plus b? A to the 2 minus b to the 2. So the answer is x4 to the 2 minus 1 to the 2. But x4 to the 2 is x8. When the power raises to the power, multiply the powers. 1 to the 2 is 1. So the answer of multiplying all of these brackets by each other is x to the 8 minus 1. And now look at these examples. 2x plus 3 times 2x plus 3. Attention here, we cannot use that identity. Because in that identity, we have to have a plus b times a minus b, or a minus b times a plus b. But here the sign is the same. Here we need another important identity. The identity that we are going to use is this. A plus b to the power of 2 is a to the 2, 2ab plus b to the 2. A to the power of 2, b to the power of 2, and 2 times the product of these two terms, 2ab, 2 times ab. And if you wonder where this formula, where this identity comes from, it's very simple. If you multiply a plus b by a plus b, attention, a plus b to the 2 is what? It's basically a plus b times a plus b. This is the meaning of power 2. If you multiply these two brackets by each other, you will see that the answer is exactly this. A times a is this a to the 2. A times b is ab, but we have another ab. B times a is ab again, ba or ab. So we have ab and another ab, which is 2ab. And b times b is b to the 2. So this is a simple but important identity, and it's good to remember for doing questions like this. So immediately here we say, okay, this is like 2x plus 3 to the 2. And for raising an expression with two terms, a binomial to the power of 2, we use this identity. If you like, simply multiply term by term, and the answer at the end would be the same. If we want to use this identity, what would be the answer? The answer is a to the 2. Attention, this is a, this is b. A to the 2, 2x to the 2. What is 2x to the 2? 2x all to the 2 is 4x to the 2. Then 2 times this times this. Try to do this in your head. 2 times by this times by this. 2 times 2x is 4x. 4x times 3 is 12x. And finally, b to the 2. b is 3. 3 to the 2 is 9. Let me explain how we got this. 2 times this. 2 times 2x, 4x. 4x times 3, because 2 times the first term times by the second term. 2 times by this is 12x. Look at the next example. Again, we are going to use this identity to raise this expression to the power of 2. The answer would be radical x to the 2 plus 2 times by radical x times by 5, 2ab, b to the 2, 5 to the 2. Radical x to the 2 is x. 2 times radical x times 5 can be written as 10 radical x, because 2 times 5 is 10, 10 times radical x. 5 to the 2 is 25. Gradually you have to skip this step and you have to jump from here to here. The first term to the 2 is this. 2 times this by this is 10 radical x. 5 to the 2 is 25. And if you want to be able to do this right away without writing this middle step, you need to practice. This is the only way that we can learn math better. Practice and practice and practice. I hope by watching this video now you have learned how to add, subtract or multiply polynomials or expressions by each other. If this video was helpful for you, please subscribe in my channel and see you in the next videos.